Now moving on to the different types of test. The tests are again the qualitative test for qualitative data, and the test for quantitative data, right? For qualitative data we have chi-square test and z-test. For quantitative data we have t-test, paired and unpaired, and z-test. If you are thinking that I am wrong of writing z-test here in the quality data, you should go and check for Mahajan, the book for Biostatistics, and all the sums with the qualitative data, they are solved with both chi-square and the z-test. So it is this both test, this z-test and this is different because they have the different formulas. Now normally we take 95% as the confidence interval if it is not mentioned in the question. 95% confidence interval is equal to 0.05 p-value. So lesser the p-value, higher is the significance. The p-value is inversely proportional to the significance. That way it is 2 points. We take 95% as confidence interval for calculating the sums at 0.05 level. And if the p-value is less than 0.1, it is highly significant. And that would be equal to 99% of the confidence interval. Now if I represent it as a diagram, then again we come to a normal curve, right? And 95% would be plus or minus 2st, that would be the 95%, and remaining 5% is equally distributed as 2.5% here and 2.5% here. Any value after calculation if comes within this area, and then it would be significant and not by chance. Let me change the cover. So suppose any value if comes between this 2.5%, when we are calculating at 95% in confidence interval, then it would be significant and not by chance. But at 95% significance level, if the calculated value is between this one plus or minus 2ht, then it is by chance and it is not significant. Therefore, when the value is not significant, we will accept null hypothesis, and if the value is significant, then we will reject the null hypothesis. So we accept the null hypothesis when it is in the 95% confidence interval. So this is also called the zone of acceptance, while when the value is in the 2.5%, and this area would be zone of rejection. Okay, so now we'll quickly look on the formulas for the tests. First of all would be the chi-square test, also known as chi-square. Here suppose we select a 2x2 table, then that would be first cell, second, third and fourth. Here would be the row total for this row, and here it would be the column total, and that would be the grand total. So the values that are given in this box are called observed values, expected values. They are attributed as O, they are attributed as E. So for this particular cell we have O1 and we need E1. This is given, this is to be found out. So for finding this particular figure, we will use the column total, this one, into row total divided by grand total. This particular formula will give us the expected value of cell 1, and similarly we will find for E2, 3 and 4. After finding out all this O1 to O4 and E1 to E4, we will use this formula O1 minus E1 whole square upon E1. This would give the chi-square value for the first cell, for this first cell, and we will find for 2, 3 and 4th cell. We will add up them, and that would give us the final chi-square value. So this value, whatever the result comes, will be looked upon in the chi-square table against a particular degree of freedom. So now we need the degree of freedom. So here there are two columns and two rows. So the degree of freedom for this particular 2 cross 2 table would be row minus 1 into column minus 1, 2 minus 1, 2 minus 1, and this is variable. It can be 3 cross 3, it can be 3 cross 2. So here we will get degree of freedom as 1. So using this one, we will see against first degree of freedom the proposed chi-square value at p less than 0.05 or 95% confidence interval. If the value is, if the calculated value greater than chi-square at degree of freedom 1 from table, then the result is significant. If not, it is by chance. So that was chi-square test. Now similarly for qualitative data, that was also for the qualitative data, we will use z-test, and here the formula is standard error of P1 minus P2 upon standard error of proportion. Here standard error proportion is given by P1 Q1 upon N1 plus P2 Q2 upon N2 whole under root. This particular value when calculated by this will give the SCP, and further these two values are given in the questions. From these two values we will find the Q1 and Q2 respectively. Sample size is also given. So only you need to find this standard error proportion using this formula, put this value here and just get the difference of P1 minus P2 and we get the Z value. Now if the Z value is greater than 1.96, this particular indicates 95% of confidence interval, while Z 2.58 indicates 99% of the confidence interval. So if the Z is more than 1.96, it is significant. If it is more than 2.58, it is highly significant. If they are less than 1.96, then it is by chance and not significant. So that was z-test for the qualitative data. For the quantitative data, okay, we have t-test, z-test. T-test are of two types: paired, unpaired. Paired basically means there are two group of populations and we will compare these both groups, and here the single group but before and after studies. This can be given as an example like 10 people with this hemoglobin. After giving them IFA tablets, we would find out again the change in the hemoglobin in that 10 patients. So the patient remains the same, and we compare before and after effects. That's unpaired t-test. Now to choose whether you have to do Z or T, we will know from this the sample size. If n is less than 30, use T. If n is more than 30, use Z. The formula remains the same. Here SE is equal to SD upon root n. Z has the same formula. If there are two groups, then we will have two values. HD1 square upon n1 plus HD2 square upon n2, and this particular value will be kept here or here and calculated. There should be the difference between means given in the question. Standard deviation can be given in the question. Sample size is always given, and so we will find the SE, standard error, and we'll keep it here. And from that we will calculate the T and Z values. Now, for the Z value, the interpretation remains the same as mentioned above, and for T values, we have to see on T table against degree of freedom. Here, degree of freedom for paired would be n1 plus n2 minus group, and degree of freedom for unpaired will be n minus 1. So against this degree of freedom, we will see the T value. If it is greater, then it is significant, and if it is lesser than the table value, it is by chance. So that was statistical exercise of the analytical studies.